Hi guys, welcome to part 2 of the unit review. We are on question 26, where we will be now focusing on solving one-step inequalities with multiplication and division. Just a little reminder that you must flip the inequality sign if you multiply or divide by a negative when solving the inequality. So for number 6, our first step is to multiply both sides by 3. Because p over 3 is the same as division, and to undo division, we multiply. So we get p is greater than 6. So we make a number line with our boundary point at 6. An open circle going to the right. Number 27, since we have a fraction in front of our variable, we know we need to multiply by the reciprocal, which is 5/3. Doing so leaves us with q is less than or equal to negative 10. You can just use your calculator for that. That's how I would do that. I don't flip the sign because I'm multiplying by a positive number. Even though there is a negative involved, I'm multiplying by a positive number, so the sign doesn't flip. Number line would have a boundary point at negative 10, an open circle shaded to the left. Number 28, I need to multiply both sides by negative 7. Doing this, it will give me negative 7 on the left side is greater than s. I had to flip the signs because I multiplied by a negative number. I don't like having the variable on the right side though, so if you want to flip it again, you could flip it a second time and get s is less than negative 7. So your number line, got my boundary point at negative 7, open circle going to the left. 29, negative 11k means I'd have to divide by negative 11. Leave me with k is greater than or equal to negative 3. And for the number line, it will be a closed circle at negative 3, shaded to the right. Number 30, we have 5j is greater than negative 20, so I divide both sides by 5. And I get j is greater than negative 4. I'm going to draw my number line. I have my boundary point at negative 4 with an open circle shaded to the right. And number 31, we're going to divide both sides by negative 2. It'll leave me with a positive 25 is greater than or equal to m. I had to flip the sign because I divide by a negative. Again, the variable's on the right side, so if you don't like the variable on the right side, you could rewrite it as m is less than or equal to 25. So we'll have a number line with our boundary point at 25, closed circle, shaded to the left. Okay, those are our one-step inequalities. For the word problem, the toll for driving on Alligator Alley is $2.50 per car. Write an inequality, or write and solve an inequality to represent the number of times someone can drive on Alligator Alley with $15. So if I only have $15, that means I need to spend less than or equal to 15. Our unknown here is how many times we can drive. So I'm going to let x be number of trips. I guess I could say number of trips times driving. So if it costs $2.50 each trip, it's going to be 2.5x is less than or equal to 15. We can then solve it by dividing by 2.5 on both sides, which will leave me with x is less than or equal to 6. You can go 6 or less times. Okay. And then number 3, this time we're moving into two-step inequalities. So your first step for 33 is to undo the minus 5 by adding 5 to both sides. That'll leave me with m over 3 is less than or equal to negative 1. I can then multiply both sides by 3 and get m is less than or equal to negative 3. I'm going to draw my number line. Hopefully this is pretty easy at this point. I got my boundary point at negative 3, closed circle, going to the left. Number 34, I need to start by undoing the minus 2 by adding 2 to both sides. This minus sign in front of the b stays with the b, so it's negative b is greater than 10. Can't have a negative b, so to get rid of it, we divide by negative 1. And it'll leave me with b is less than negative 10. Divided by negative 1, so that is why I flipped the sign from greater than to less than. And then you can draw your number line, boundary point at negative 10, open circle, to the left. Okay, on page left. Number 35. First step is to subtract 4 from both sides. Right, I was trying to get what's with your variable last. So that's going to leave me with n over negative 3 is less than negative 13. To undo the dividing by negative 3, we multiply both sides by negative 3. We get n is greater than 39. Number line should look like this. Number 36. First thing is we need to subtract 7 from both sides. We'll leave me with 7x is less than or equal to negative 63. Divide by 7 on both sides. And we get x is less than or equal to negative 9. So our number line then, I'm just going to draw it over here. It's going to be a closed circle going to the left. 37 and 38 look a little tricky, but for 37 our first step is going to be dividing both sides by negative 4. That will leave me with 3 plus n is less than positive 8. Subtract 3 from both sides. I'm going to write it over here. N is less than 5. So our graph should look like this. 38, our first step is to get rid of this divide by 15. So I'm going to start by multiplying both sides by negative 15. The reason we do that is this and this will go away. So I'll be left with 9 plus a is less than or equal to, sign flips because I multiplied by a negative, negative 15. Subtract 9 from both sides and we get a is less than or equal to negative 24. Closed circle, shaded to the left. And the only questions we got left are the word problems. Let's go through those quick. Daniel had $25 to spend at the fair. If the admission to the fair is $4 and the rides cost $1.50 each, what is the greatest number of rides that Daniel can go on? So start by defining your variable. X is going to be number of rides. Daniel had $25 to spend at the fair. That means he can spend up to $25, or he can spend everything less than or equal to $25. If the admissions to the fair cost $4 and the rides cost $1.50 each. What's the greatest number of rides you can ride? So X is the number of rides. So when we think to ourselves, does it make more sense for X to belong to the $4 admissions fee or the $1.50 per ride? Hopefully it makes more sense that the X would belong to the dollars per ride. So it's going to be 1.5x plus 4 is less than or equal to 25. So to solve it, we subtract 4 from both sides. You get 1.5x is less than or equal to 21. Divide by 1.5. We get x is less than or equal to, let me pull out my calculator for a second. $14. So you can ride 14 or less rides if it goes to the fair. So when you graph it, we just got to make a number line. Boundary point at 14, closed circle, going to the left. Number 40, you are in debt $80, right? In debt means you are losing money or you are in the negatives, you don't have that money. You earn $12 per week. How many weeks until you have at least $250? So defining our variable, x is going to be the number of weeks we are saving for. We know we want to have at least $250, so we're going to have greater than or equal to 250. You earn $12 per week, so it will be 12x. We're in debt $80, so it will be minus 80. To solve it, we can add 80 to both sides. So we get 12x is greater than or equal to 330. Divide by 12 on both sides. We get x is greater than or equal to, I believe you should get a decimal for this, 27.5. So hopefully you can think about that. Can I save for 27.5 weeks? Can't really save with a half of a week. So in reality, if we want to have at least $250, we'd have to save for 28 weeks, not 27. Then to graph it, make a number line. Our boundary point of 27.5. Closed circle. Shaded to the right. Alright. Hopefully this helped. If you have any other questions, please email Ms. Leister or myself, and we'll help you. Good luck with your test tomorrow. Have a great weekend. Bye, y'all.